Now, Fibonacci sequence. A Fibonacci sequence is a series of numbers where a number is found by adding up to the two numbers before it, starting with 0 and 1. The sequence goes 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and so forth. Written as a rule, the expression is x sub n equals to x sub n minus 1 plus x sub n minus 2. For example, 8. We found 8 by adding 5 plus 3. 5 is the previous number before 8, and 3 is the previous number before 5. So this is the x sub n minus 1, and this is the x sub n minus 2. Another example, let's say 34. We found 34 when we added 21 plus 13. That is a Fibonacci sequence. The Fibonacci sequence was named after Fibonacci, or also known as Leonardo of Pisa or Leonardo Pisano. Now let us illustrate the Fibonacci sequence using rabbits. Let's say we have one pair of rabbits. Now it is said that it takes 1 month for the rabbits to mature and produce their own babies. And so for the next month, we still have one pair. Then after next month, when they are already mature to produce babies, then we have another pair of newly born rabbits. It is said that a pair of rabbit can only produce one pair of baby rabbits. And so, for this particular month, we already have 2 pairs of rabbits. Now for the next month, our parent rabbit have already produced another baby rabbits. But for this particular baby rabbits, they have just matured. And so, for this particular month, we already have 3 pairs. Then for another month, for the next month, our parent rabbit have produced another baby. And for this previous baby have already matured. But for this particular, the firstborn babies, since they have already matured, they were able to produce another pair of rabbits. And so for this particular month, we already have 5 pairs of rabbits. And for another month, we already have 8 pairs of rabbits. And that is how Fibonacci sequence can be illustrated using the rabbits. Now, Fibonacci numbers can also be seen in nature. Like for example, the white calla lily, it contains 1 petal. Euphorbia contains 2 petals. Trillium contains 3 petals. Columbine contains 5 petals. Bloodroot contains 8 petals. Now, most, if not all, of the flowers has number of petals that are seen or is found in Fibonacci sequence. So mostly we can only find either 1, 2, 3, 5, 8, and so on and so forth. Now, a Fibonacci sequence can also be seen in the way three branches form or split. So, for example, here we have 1, then here 2 branches, and then here we already have 3, then here we already have 5. And this kind of tree is what we call Smith's worth. The golden ratio was first called as the divine proportion in the early 1500s in Leonardo da Vinci works, which was explored by Luca Pacioli, entitled The Divina Proportione in 1509. Now, in mathematics, two quantities are in the golden ratio if their ratio is the same of their sum to the larger of the two quantities. So let's say, for example, we have this illustration where the length of A is greater than the length of B. And this one is when we add A and B. Now, the golden ratio is illustrated in this way, in which the sum of A and B divided by A is equal to when we divide A to B, and that is equal to 1.618. And it is represented by a pi. Now again, the golden ratio, the value of golden ratio is infinite. So we have 3 dots here. Okay, so this is continuous. It will not, the value will not end at 7. Now the golden rectangle is called the perfect rectangle by some. It is a rectangle in which the ratio of its length, the length, to its width is the golden ratio. So as, if we're going to recall, we have A plus B all over A. Okay, that is the golden ratio. Now, a golden rectangle can be broken down into squares, the size of the next Fibonacci number down and below. If we were to take a golden rectangle, break it down to smaller squares based from Fibonacci sequence, and divide each with an arc, the pattern begins to take shapes. We begin with Fibonacci spiral, in which we can see in nature. So this is the example of it, in which this small square has 1 as the measurement of its length. Okay, and then this square, it has 3 as the dimension of the side. Then this one is 5. Then this one is 8. Then this one is 13. Then 21, 34, and 55. So this is just an example of a golden rectangle where we can see the Fibonacci sequence. Now the golden ratio can also be found in some of the arts. Okay, and then we can find it in the architectural designs, in some of the paintings as well.